Hello there and welcome to another computer science video. In this one we're going to look at the programming of the insertion sort. So I'm going to continue on from my bubble sort program and I'm just going to adapt this so that it actually does the insertion sort as well. So if you've not seen the bubble sort video already, it's worthwhile going back. Make sure you got that code already because we're going to use some of the procedures that we've made to continue in this one. So I've just added another button there. I'm going to call this one insertion sort. And I'm going to change its name as well because it's called button 1 at the moment, which is a terrible self-documenting identifier. So btn insert. There we go. So once that's done, I'm just going to double click that button and remember what an insertion sort actually does. It builds a sorted list as we ascend through our list. So we can always assume that once we've passed the number and it's been put in its rightful place, then it is sorted. So the first thing I'm going to do is I'm going to make a couple of variables. I'm going to use the variable I, j, and n. Now it doesn't matter what these are. You can call these whatever you like because they are local variables. I'm going to call one current item actually because it's going to hold or point to the current item. And they're all integers because they're just indexes. They are element references because again we still use an array in an insertion sort. And then I'm going to have another one called inserted, and that is going to be a boolean, if I can spell it correctly. There we go. So boolean is true or false. Has it been inserted or has it not been inserted? Then I need the number of elements in my list. So how many elements do I have? I'm going to use the upper bound function. And all that does there, it says it returns the highest available subscript for the indicated dimension of the array. So basically it tells us how many elements are in my array. So in there, my array is called my array, funnily enough. So that's going to return that and put it in n. So n is going to hold the number of elements I've got. Now I've referenced my array here because this is from my bubble sort program. I've got a global array called my array. So that's what that means there. That's where it's come from. And then what I'm going to do now is, similar to a bubble sort, we have two loops in here. So the first one, for I equals 1. Notice we don't start at 0, okay? Now, we don't start at 0 because if we had just 0 elements in there, or 1 element of position 0, it would already be sorted if we had one number. So we start at 1, and then we go back and look behind us. And that you'll see that all the way through the insertion sort. Now, if we start at 1, we're going to have to minus 1 from the list, just to keep us in the right bounds of the array. Now, what I'll do is I'll set the current item to equal my array at the position of I. Now, that keeps a copy of whatever value is in my array at the position of I. So in the first pass, I is going to be 1, isn't it? So it's going to hold whatever's at my array, position I, and put it inside current item. And that stops us overwriting it later on. Then we say inserted equals false. Why? Because we haven't inserted our number yet. And then j equals I minus 1. Now if you think about it, I is 1 on the first pass. It says that right here. So minus 1 makes it 0. So it's basically I is looking at the current number. And then j looks at the current number minus 1, so previous to I. So it looks behind it. And that is a feature that you'll see of the insertion sort all the way through this. Now, we're going to use a do while loop here. And we're going to say, continue to loop while j is greater than or equal to and inserted equals false. Okay? So while we haven't inserted it, and while j is greater than or equal to 0, then keep going. Now j greater than or equal to 0 means that you are still higher than 0 in your list. So there must still be numbers to actually go through. So j actually decrements or goes down through the list down to position 0. And then j will be set to minus 1 at some point, which means it's outside of the bounds because the bottom of your array is position 0. So if we look at minus 1, then that's outside the bounds of the array and it will fail that loop and it will stop there. Okay, the inserted part is false, so while we haven't inserted it, so keep going. We need to find its rightful place. So if we keep looking, what this is going to do, this is going to say if current item is less than my array at the position of j, then what we're going to do is we're going to set my array at the position of j plus 1 to equal my array j. Okay? And what that does is that makes a swap. So that swapping happens actually overwrites j plus 1, which means this j here position actually gets overwritten. Now what I'd recommend is you actually drawing an array, putting some numbers in it, and then running this algorithm. Because just by staring at it, it will not make sense. Because why is j being set to j minus 1? And this is because it decrements down the list, checks each number until we've found its rightful position, and inserts it there. So my array j plus 1 is then given the value of current item. And that's when the swap is made. Okay, so what I'll do is I'll put some comments in here. And then if the current item is less than my array at position j up here, then we make a swap. But if not, we don't make a swap, then we're going to insert it into its position. So the inserted Boolean variable would be true. Then we finish the loop, and that's it. So let me just recap that again for you. We have I, j, and n along with current item. N is the list upper bound, so how many elements have you got in your list? I holds the current position, and j holds the current position minus 1. So it looks behind the current position. The inserted variable is a Boolean, so it's true or false. Have you inserted it? Yes or no. And that will go down the list. Now while j is greater than or equal to 0, so while we've still got numbers to loop through and we've not inserted it yet, we're going to check to see if the current item we're looking at is less than my array at the position of j. So the current item is basically I, position I in the array. My array j is the one behind I. Then if the current item is less than my array j, then what we do is we make a swap. So we say my array at j plus 1 is given my array j. J equals j minus 1, so we decrement down the list and move down. And then we say my array j plus 1 is given the current item. And that prevents overwriting and duplication. So this part here, I strongly recommend you getting a little whiteboard, a piece of paper, drawing an array of however many elements you like, put it all together, run this and see what happens. And this is really important, this line here, this decrementation, because this is our base case. This is what tells us to either break out the loop or not. And if we fail this condition and we don't need to make a swap, then it must be inserted into the rightful position. And that's it. And all I need to do at the end here is call my output procedure to actually output it into the list. So now, if I run this, my program asks me how many elements. I say 15 elements. It then produces. I click populate the array. There we are. There's my 15 elements. And then I click insertion sort there. And then you'll see all my numbers have been sorted in ascending order. And that's it. That's how our insertion sort works.